We've defined distance and time and speed. The speed we've been calculating is a constant speed over a short period of time. Another name for that is called instantaneous speed. Now, what if you have a trip with multiple parts? We're going to have to treat each part separately. In this case, where we have separate parts, where possibly we have different speeds at each part, we can now calculate the average speed of the entire trip. We're going to find that by getting the total distance you travel and divide that by the total time it took you to travel that distance. A very handy tool in doing physics is the use of subscripts. Okay, you may be familiar with them in English class, history class, but what we do in physics, if you have a multiple trip, for example, you have 3 parts, you travel one distance, then a second distance, and a third distance. The way that we tell them apart, we label the first one D1, then D2, D3, or if you'd like, D sub 1, D sub 2, D3, and each time interval would now be T1 or T sub 1, which obviously matches up with D1, and then T2 and T3. Here's how we're going to use these subscripts to help us solve this problem where you're moving at different speeds and different time intervals, different distances and different time intervals. First, you're going to find the total distance moved. And again, we'll use a subscript. This time we're going to call it D sub total. You could even abbreviate that D sub T. And that'll equal to D1 plus D2 plus D3. Each one of those are the various distances you covered. Then your time total will be T1 plus T2 plus T3. Again, for each interval, interval 1 took you T1. And then to find the average speed, and we're going to call that speed average, or S sub AVG, AVG stands for average, we take the total distance traveled divided by the total time. Here's our first example. There's a student riding her bike home from school by way of a friend's house. It takes this student 7 minutes. Now remember, we do not use minutes for time. We have to translate that to seconds. So in this case, that's 420 seconds. And she has to travel 2,500 meters to the house. The student then spends 10 minutes at the house before traveling 3,500 meters to your house in 9 minutes. What was the average speed for this trip? This seems very tricky and complex, so we have a nice way of organizing this so it'll make sense. We're going to use a table. Here's the table we're going to use. We're going to call each part of the trip a segment, and you have segments 1, 2, and 3. And then at the bottom we're going to total up the total distance traveled and the total time traveled. So for each segment, we'll put down how far the student went, how long the student spent at that distance, and then over here we can calculate speeds. And the whole idea is to calculate the average speed for this trip. Once the table is drawn out, an excellent next step is to underline the various givens. And you can see this in red here. That would be your interval 1. The blue line is interval 2. And the green underline is interval 3. Notice how all the minutes have been converted to seconds, and all the distances, of course, are in meters. Let's start with interval 1 or segment 1. The person, the female student there, traveled distance of 2,500 meters, and you can see where that was put right here in the chart. And the time she took was 7 minutes, but again, we do not use minutes, we use seconds, so that's 420 seconds. So right now we're just putting data into the table. We are not doing any calculations. Step 2 is using the given information to find the total distance and the total time. You can see here how between the last slide and this slide, we filled in the distance spent in the second segment, how much time the student spent there, and you can see we have 0 here. That meant she didn't go anywhere. She was staying at her friend's house, so 0 meters were traveled. The third segment, it was 3,500 meters in a time of 540 seconds. So what we're going to do now is add these three values, and we'll fill in this box here, and the same thing for time. We'll add the 3 time intervals to get a total time interval. The total distance traveled was 2,500 meters plus 3,500 meters plus 0. Again, this is the place where the student wasn't moving. You total them up, you get a total trip distance, or a D total, of 6,000 meters. Next, we will do the total time. Step 3 will be to use the formula we discussed a little bit earlier, where the average speed equals the total distance divided by the total time. And you can see that's right over here. And this is going to give us our average speed. In the meantime, we had added the times up and got a total time of 1,560 seconds. We will divide 6,000 by 1,560 and fill in this box over here. So we have now divided the total distance traveled, which is 6,000 meters, by 1,560 seconds, and over here we have 3.85 meters per second. Notice how the units come out very nicely just by following the equation. We have meters over here divided by seconds, that's meters per second. And also notice how when we filled out the table, we didn't have to put the units in each cell. The reason we didn't is up here in the title we put what kind of units we'd be using. So that saves a little space when we fill out each cell of the table. Here's an example you can work in your groups or by yourself. We have the same table that we've used before, and in this case it's a slightly different problem. You run a distance of 210 meters at a speed of 7 meters per second. You then jog a distance of 800 meters in a time of 235 seconds. Finally, you run for 25 seconds at a speed of 6 meters per second. This is a little bit different. Notice earlier we didn't use these cells at all, but now it looks like we're going to have to use them. So take a few moments, try and solve this problem, and on the next page we'll show you the answer. This example was a little different than the first one. It proceeded much as the first problem, where we were given a distance, 210 meters here, 30 seconds, filled in these two cells. The second interval was 800 meters at 235 seconds. However, the third one was a little different. They gave us the time over here, 25 seconds, and the speed, which was 6 meters per second. Now we know we needed the total distance for our average speed formula. So what we had to do is fill in this cell here. Well, we had the time and the speed. So we know that the speed is equal to the distance over time. So since we had time and speed, we can find the distance just by doing a little algebra here. D is equal to the speed times the time. We multiplied 6 by 25. We received an answer of 150 meters. You add the three distances up. You have 1160. Your time was 290 seconds. You divided them and you received an answer of 4 meters per second. Now, let's say we took the average speeds for the other two segments and we found out that they were 7 meters per second and 3 meters per second. Do you get the same answer? Here, this is our answer. That's our average speed for the trip of 4 meters per second. What if you average these three up? Do you get the same answer? And if not, why not? So take a couple seconds and think about that one. Did you come up with an answer for why, if you average the different speeds for each segment, which is 7 meters per second, 3 meters per second, and 6 meters per second, when you average the three of them, you don't get 4 meters per second? Well, let's see what you did get. If you add 7 plus 3 plus 6, you get 16. You divide that by 3, you get 5.3 meters per second, which is not 4 meters per second. What happens is you spent more time, you spent 235 seconds at 3 meters per second in your trip. So this 3 should have a much greater weight on your total average speed. And it in fact does, because we found that the average speed was 4 meters per second, which is less than the 5.3 if you just average these 3 on equal footings. You can't. They're at different times. So when you work these problems, the only way to find this lower right-hand corner, the total average speed of your trip, is to find the total distance, which is here, and the total time, divide them, and here you get 4 meters per second, which is your average time for the trip.